Good afternoon everyone. So let us look at the strain displacement relation today. Alright. We have discussed about epsilon x, epsilon y, gamma xy and all the other components. So let us try to arrive at the strain displacement relation. This is y-axis, this is x-axis, this is origin. So I am going to consider lines PQ and then PR. So these lines are going to be displaced, yes, so that the new lines be P dash, Q dash, P dash, R dash. So let this be U, this be Y, so this is going to be V. This is going to be V. The initial length of PQ, let it be del X. Initial length of PR, let it be del Y. I'm going to extend PQ to Q double dash, extend R to R double dash. Alright, now the length from PQ double dash to PQ dash along x-axis in the y direction is V plus dou V by dou x into delta x. Distance between Q and Q dash is U plus dou U by dou x into delta x. Similarly, the length between R and R double dash is V plus dou V by dou y into delta y, and distance between R double dash and R dash is U plus dou U by dou y into delta y. So all the components of strain are considered to be very small, so that the material is subjected to strain within the proportional limit. We have considered two line elements PQ and PR at a point of length delta x, delta y. The components of displacement of the point, say P, x, y, B, U and V. The lines will be deformed to form PQ dash, P dash Q dash and P dash R dash due to the action of stresses. So please observe this one thing here. We are writing with respect to elongation of PQ. Hence you have dou U by dou x into delta x. Now it's all again with respect to x that we are writing, so it is V plus dou V by dou x into delta x. Here we are writing with respect to vertical direction PR, hence it is dou V by dou y into delta y, and then PR and then P dash R dash is U plus dou U by dou y into delta y. Alright, so going forward to find net elongation of PQ, that is nothing but delta x, and this is along x direction. I can write it as U plus dou U by dou x into delta x minus U. U gets cancelled, so it is dou U by dou x into delta x. Epsilon x is nothing but strain along x direction, so this is change in the length divided by original length. So change in length is dou U by dou x into delta x. Original length is delta x. Delta x gets cancelled, so it is dou U by dou x. Similarly, I can write net elongation of PR is equal to delta y in y direction. So it is v plus dou v by dou y into delta y minus v, and this is nothing but dou v by dou y into delta y. V gets cancelled, or epsilon y is change in length divided by original length. So it is dou v by dou y. We have arrived at epsilon x value, epsilon y value. Now we will be arriving the shear strain value. Alright, so for shearing strain, alright, let us consider the change in the angle between the two line elements. So the two line elements are nothing but PQ and PR. So here let us consider the angle formed is alpha 1 and alpha 2. We will be considering these two angles in order to arrive at the shear strain value. Alright, so gamma xy is alpha 1 plus alpha 2. I told you in the beginning that the shear strain is going to be so small that it is going to be within the proportional limit. Strain is going to obey the Hooke's law. Since alpha is small, I can write tan alpha 1 is almost equal to alpha 1 and tan alpha 2 is almost equal to alpha 2, or alpha 1 is dou v by dou x into delta x divided by delta x, which is dou v by dou x, since p dash q double dash is equal to delta x. Similarly, I can write alpha 2 as dou u by dou y, or gamma xy, which is alpha 1 plus alpha 2, is equal to dou v by dou x plus dou u by dou y. We have arrived at the value of strain, that is gamma xy. Now let us write all the components of this strain in terms of displacement components. Alright, I am rewriting components of strain in terms of displacement components. So we have to consider it in the form of a figure. It's nothing but a strain. So let us call this as PQRS. The length of PR is dy. Length of PQ is dx, and this is going to be our shearing strain, gamma xy, which is dou v by dou x plus dou u by dou y. So epsilon x is dou u by dou x, epsilon y is dou v by dou y, epsilon z is dou w by dou z. We will be not considering epsilon z because I have considered a plane. Okay, so we will be considering only x and y. Gamma xy is dou v by dou x plus dou u by dou y, or gamma xy can be written as epsilon xy plus epsilon yx, which is nothing but 2 times epsilon xy, or I can rewrite epsilon xy as half of gamma xy, epsilon yz as half of gamma yz, epsilon zx as half of gamma zx. Yes, we have just established a relation between epsilon and gamma, normal strain and shear strain. I can write a strain tensor now. We will be rewriting strain tensor, that is epsilon, which is equal to epsilon x, epsilon xy, epsilon xz, epsilon yx, epsilon y, epsilon yz, epsilon zx, epsilon zy, epsilon z. So this can be rewritten as epsilon x gamma xy by 2, gamma xz by 2, gamma yx by 2, epsilon y, gamma yz by 2, gamma zx by 2, gamma zy by 2, epsilon z. We have rewritten the strain tensor, or I can also write this as epsilon times d into u. So d is nothing but an operator matrix. Operator is nothing but dou by dou x, dou by dou y, dou by dou z. So I can rewrite it in terms of operator matrix as epsilon x, epsilon y, epsilon z, gamma xy, gamma yz, gamma zx. So this is equal to dou by dou x. What is epsilon x is equal to? It is dou u by dou x. So let us fill this first. Dou u by dou x. Y is 0, z is 0. What is epsilon y? Dou v by dou y. So 0, dou by dou y. Dou v by dou y and 0. What is epsilon z? Dou w by dou z. So dou z. What is epsilon xy? Epsilon xy is nothing but dou v by dou x plus dou u by dou y. Then epsilon yz. Alright, so it is going to be dou w by dou y plus dou v by dou z. Then gamma xy yz zx. So it is dou u by dou z plus dou w by dou x. So gamma xy in the place of x. So it is going to be, the first term is dou v by dou x and the second one is dou u by dou y. Here we have u, v, w. So first you have to fill up the denominator of u. The denominator of u is dou by dou y. So write dou by dou y. Next, the denominator of v is dou by dou x. Dou by dou x. You do not have a w term, so 0. Next, gamma yz. Gamma yz. Do you have a denominator for u? No. Do we have a denominator for y? Yes. That is dou by dou z. Dou by dou z. Do we have a denominator for w? Yes. That is dou by dou y. Last, gamma zx. Do we have a denominator for u? Denominator for u is dou by dou z. Do we have a denominator for v here? No. So 0. Do we have a denominator for w? Yes. So it is dou by dou z. This is the matrix. Now let us arrive at the formula for strain components at a given point in any direction. Alright, strain components at a given point in any direction. Let us consider x, y origin. So let me consider a line p, q. So it gets displaced as p dash, q dash. Let the distance be dx along x direction, dy along y direction, and let the length be PQ. Let it make an angle theta. Alright, now let's write the coordinate. For P, coordinate is x comma y. For Q, the coordinate is x plus delta x comma y plus delta y. Alright, we have written the coordinates. Now let us arrive at normal strain and then shear strain value. Normal strain, that is inclined at an angle theta with x-axis is given by epsilon theta as epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 times cos 2 theta plus gamma xy by 2 sin 2 theta. Now coming for the shear strain, so that is gamma theta, that is nothing but epsilon y minus epsilon x times sin 2 theta plus gamma xy times cos 2 theta.